Hi and welcome to John's Maths book. In this video we're going to be looking at dividing two complex numbers. If you like the video then please hit the like button and I'd be delighted and honoured if you'd subscribe to the channel. Without further ado, let's go to the whiteboard. Let's look at how we divide complex numbers. Our goal here is to produce a new complex number of the form a plus bi, where a is the real part and bi is the imaginary part of the complex number. I'm going to use the example 6 plus 3i divided by 2 plus 7i to demonstrate the technique for achieving this. To achieve our goal, we need to convert the denominator of the fraction into a real number. We can do this by multiplying both numerator and denominator by the complex conjugate of the denominator. The denominator is 2 plus 7i. So to get the complex conjugate, we replace the plus sign with a minus sign to give 2 minus 7i. If this sign was negative, we'd replace the negative sign with a positive sign. So we now have 6 plus 3i divided by 2 plus 7i multiplied by 2 minus 7i divided by 2 minus 7i. Now we need to multiply the complex numbers in the numerator and denominator together and then simplify. Beginning with the numerator, 6 multiplied by 2 gives us 12. 6 multiplied by minus 7i gives us minus 42i. 3i multiplied by 2 gives us 6i. And 3i multiplied by minus 7i gives us minus 21i squared. And moving on to the denominator, 2 multiplied by 2 gives us 4. 2 multiplied by minus 7i gives us minus 14i. 7i multiplied by 2 gives us 14i, and 7i multiplied by minus 7i gives us minus 49i squared. Simplifying the numerator, we have 12 minus 42i plus 6i gives minus 36i, and minus 21i squared gives plus 21, because I squared is equal to minus 1. And minus 1 multiplied by minus 21 gives plus 21. And in the denominator, minus 14i cancels with plus 14i, and we're left with 4. And minus 49i squared gives plus 49, because I squared is equal to minus 1, and minus 1 multiplied by minus 49 gives 49. Simplifying the fraction further, 12 plus 21 gives 33, minus 36i, and in the denominator, 4 plus 49 gives 53. So we've now achieved our goal of making the denominator a real number. So our new complex number in the form a plus bi is 33 divided by 53 minus 36i divided by 53. In our second example, let's divide the complex numbers 2 plus 5i by 3 minus 2i. To eliminate the complex number in the denominator and make it a real number, we multiply both numerator and denominator by the complex conjugate of the denominator. So in this case, the complex conjugate is 3 plus 2i. So we multiply both numerator and denominator by 3 plus 2i. And now if we multiply both numerator and denominator out, we have 2 multiplied by 3, which gives us 6. 2 multiplied by 2i gives us 4i. 5i multiplied by 3 gives us plus 15i. And 5i multiplied by plus 2i gives us plus 10i squared. And in the denominator, 3 multiplied by 3 gives us 9. 3 multiplied by 2i gives us 6i. Minus 2i multiplied by 3 gives us minus 6i. And minus 2i multiplied by 2i gives us minus 4i squared. Simplifying both numerator and denominator, and starting with the numerator, we have 6. 4i plus 15i gives 19i, and 10i squared gives minus 10, because I squared is minus 1, and minus 1 multiplied by 10 gives minus 10. And in the denominator, we have 9, positive 6i, cancels with negative 6i, and we have minus 4i squared, which gives plus 4, because I squared is minus 1, and minus 1 multiplied by minus 4 gives plus 4. And simplifying this further, 6 minus 10 gives minus 4, plus 19i, divided by 9 plus 4, which is equal to 13. So we now have a real number in the denominator. And putting this in the form a plus bi, we have our final answer of minus 4 divided by 13 plus 19 divided by 13 multiplied by I. And in our third example, let's divide the complex number 3 minus 4i by 2 minus 6i. So the conjugate of the denominator is 2 plus 6i. So we need to multiply both numerator and denominator by 2 plus 6i. So starting with the numerator, 3 multiplied by 2 gives 6. 3 multiplied by 6i gives plus 18i. Minus 4i multiplied by 2 gives minus 8i. And minus 4i multiplied by 6i gives minus 24i squared. And in the denominator, 2 multiplied by 2 gives 4. 2 multiplied by 6i gives 12i. Minus 6i multiplied by 2 gives minus 12i. And minus 6i multiplied by 6i gives minus 36i squared. Simplifying the numerator, we have 6. 18i minus 8i gives 10i. And minus 24i squared gives plus 24, because I squared is minus 1, and minus 1 multiplied by minus 24 gives 24. In the denominator, we have 4. Positive 12i cancels with negative 12i, and we have plus 36, as I squared is minus 1, and minus 1 multiplied by minus 36 gives 36. Simplifying the numerator, we have 6 plus 24, which gives 30, plus 10i. And in the denominator, we have 4 plus 36, which is 40. So we now have a real number in the denominator. If we now divide both numerator and denominator by 10, we can get our new complex number into the format a plus bi. So we have 3/4 plus I divided by 4, which is our final answer. For our final example, let's divide the complex number 2 plus 3i by the square root of 2 multiplied by I. To do this, we need to multiply both numerator and denominator by the conjugate of the denominator. The conjugate of the denominator is minus the square root of 2 multiplied by I. Distributing this in the numerator, we have 2 multiplied by minus square root of 2i, which gives minus 2 multiplied by the square root of 2i, and 3i multiplied by minus the square root of 2i gives minus 3 multiplied by the square root of 2i squared. And in the denominator, the square root of 2i multiplied by minus the square root of 2i gives minus 2i squared. Simplifying both numerator and denominator, we have minus 2 multiplied by the square root of 2i plus 3 multiplied by the square root of 2, because I squared is minus 1, and minus 1 multiplied by minus 3 multiplied by the square root of 2 gives 3 multiplied by the square root of 2. And in the denominator, we get 2, because minus 2i squared becomes minus 2 multiplied by minus 1, as I squared is equal to minus 1, which gives 2. So now if we put this in the form a plus bi, we get 3 divided by 2 multiplied by the square root of 2 minus the square root of 2i, which is our final answer.